Welcome to our discussion on the DC microgrid and the control system. Today we will talk about the intelligent control in the microgrid applications. So, our presentation layout will be the upper introduction, that is intelligent control technologies. We shall talk about detail with fuzzy logic control, then fuzzy logic system as main controller, which we have discussed in previous class. Fuzzy logic control for tuning and fuzzy logic control as a supplementary controller. So, we shall see all those aspects how fuzzy logic FLC is used. And so, recently the intelligent control system application has received increasing attentions, because ultimately when you have a conventional PI controller and other issues, challenges is mainly to tune the PI controller, and it works when you know the transfer function very well, and most of the cases it is difficult to derive the transfer function, and since the system is nonlinear, so it does not function very well. So, you have to take a help of the nonlinear controller. And instead of the nonlinear controller, many researchers are now putting their observation as well as the research on the FLC, and thus it became an emerging field in FLC or ANN based or any other intelligent controller being applied for the microgrid operation. In microgrid operation, so intelligent control can be applied planning, control as well as the management. So, that is what I was telling, that numerous research work indicates that applicability of the intelligent approaches in microgrids. So, there are many research papers on this intelligent control. And why it is so? It is because simplicity, because if you understand, because our world is fuzzy. Our world is not script set, it is human who actually talk about the script sets. Like for example, I am a faculty of IIT rookie, and if someone is not faculty of IIT rookie, it does not belong to our set. But it is not like practical cases, like when you say that today is warm or cold, it is not like that script set. Since it works in our human linguistic hedges, so it has got a huge advantage to use it when you have a it has got a attenuations or understanding with the human languages. That is one of the biggest aspects and helpful while actually describing the fuzzy set, and for this reason it is simple. So, while setting a task of the FLC, a general layman will find more comfortable. Of course, mathematicians may have opinion on the script set of the fuzzy set, that what about the stability studies and all, but it is simple. Smart, if you design very intelligently, it will become a smart. It has a flexibility. So, flexibility also it can take its own decision, and thus it can have a different kind of flexibility can be incorporated here of the artificial intelligent control approach. So, it is a self correcting actor, increasing interest in applications of the intelligent technologies such as knowledge based expert system. You have a trend data sets, or you know that input and output, and then you try to interpolate this data in between, that is called knowledge based system. Fuzzy system, fuzzy and ANN almost a same kind of system. So, fuzzy and there are artificial neural networks. Then you may have a heuristic system of optimizations. These are different search algorithms, these are genetic algorithm and search based particle swap optimizations and colony, name you know better than me perhaps, search based evolutionary algorithm and other intelligent technologies that can find its applications in microgrid, and huge amount of paper you will find has been devoted on it. So, the microgrid stability and the control and synthesis have been augmented with the valuable research contributions in the past decade. So, it has been the contribution because it is a decade of the intelligent control, and thus this micro application of the microgrid finds a lot of applications in intelligent control. Significant improvement have been appeared in the area of the control synthesis to cope with the uncertainties, various load characteristics, changing structures, integration of the high rate of renewable energy sources and the energy storage element. So, these are few aspects that forces us to use the intelligent control. And in recent years, some of the advancement of the modern intelligent control methods are definitely the ANN. So, it is evolving from 70s. Professor Chade is an Iranian professor. He came out first the fuzzy sets, and so that is something it has been extensively used in the microgrid applications, FLC controller, multi-agent system, that is MAS. So, that is also used for the multi optimization technique. Thereafter, you may have a particle shown optimization technique, that is PSO, and another optimization technique is aspired from our evaluations. It has been considered that our kids are much smarter than us. It is because of the evaluations, and that entity has been taken into the consideration while designing the controller, and it is works on the optimization technique and the heuristic optimization technique. And but this too has a convergence problem, and for this reason hybrid intelligence technique is used, where you have a normal gradient based optimization technique, then you couple with this genetic and the particle swarm and other optimization technique to get a better results. So, that is the hybrid intelligent techniques. Now, let us first discuss about the fuzzy logic controller. We abbreviate as FLC sometime. Due to the simplicity, why simple? Because it works on the linguistic edges, and that is the human beings are familiar with. The robustness, and you give a number to your membership functions. Say you say actually in your cities, if the 40 degrees centigrade you say is the hottest, if it is 30 you say warm. So, accordingly in case of the hot, what should be the membership function, you can linearly define sometime, and for this reason it is simple. It is robust because it has its own fault tolerant capability, and model free property, that is one of the biggest problem we require to make a model and ultimately while designing the prototype. So, if you know this, when you are scaling down or scaling up, you require to know the knowledge of the mathematical model. So, that mathematical model knowledge is not required in case of the fuzzy logic. So, you can scale it down and scale it up, so without having the knowledge of the model. And reliability, it has been proven that it is quite reliable, and for this reason fuzzy logic is used in most of the field of the science and technologies, including solving a wide range of the control problem in power grids and operation. So, it works, that is the advantage of it. From the field, engineers are saying these are the words: simplicity, robustness, and reliable. So, what is the difference with the traditional control theories? Unlike traditional control theorem, they are essentially based on the linearized mathematical model, because world is non-linear. Once you apply the linear control system, that is the knowledge base the human being is having, ultimately it zeroes down everything to the second order system, second order linear system, and talk in terms of the Bode plot, Nyquist plot and blah blah blah. And that is what happened. Try to approximate neighborhood of this nonlinear system, but it has a lot of problem. So, it will act only close to its neighborhood, not very far behind. So, models of the control systems are to be mathematically driven, and it is merely an approximation. And on the other hand, the fuzzy logic methodology tries to establish the controller directly based on the measurements, long term experiences and the knowledge domain of the experts or the operators. So, when you know the cause and effect relations, that is basically the fuzzy expert system. You know, if it is a worm, you require to put this cloth. Say if it is a fuzzy logic control washing machine, you know that if the cloth is dirty and the cloth is jeans, so this will be the time has to be set for your washing machine, that is a rule base. The application of the fuzzy logic in microgrid system can be classified into the three categories. Using fuzzy logic system as a main controller, you have seen that is mostly in a master slave controller, that can be a main controller. Using fuzzy logic system as premier for turning gains of the existing controller, you may have a different, as you have seen that you have a different controller in a peer to peer network, you require to have PQ controller, and we have discussed so many PI controller. Ultimately, this PI controller will act well if you have optimally designed the value of the Kp and Ki. And for this reason, that getting the closest approximation or the best approximations of the PI controllers, we can use the help of the fuzzy logic without having the knowledge of the plant. So, in that area also fuzzy logic can work. So, that is what it says, using fuzzy logic system as a premier for tuning the gains of the existing controller. And what else? Using the fuzzy unit to support and sometime parallel with the conventional controller. So, you have to put it into the parallel, whosoever gives the best results, you will take it. And you may not discard, because you have a conventional wisdom on the PI controller. You take the juice from the PI controller. Once you see that actually, you know, it has overshoot is more, because it ultimately it boils down to the everything in the second order system. Its settling time is more, is and you cannot do anything. You find that ultimately tuning everything, you got a controller whose gain margin, phase margin has a problem. And in that case, we put an extra controller parallel to it. Once we find that okay, it is not possible to beyond with the conventional controller, let us put up another FLC controller parallel to it. Ultimately, it will fine tune the process, or it will take the steps based on the error. So, this is the fuzzy logic system as a main controller. This is the block diagram of it. You have the actual measure status, that is feedback signal, thereafter it will undergo some processes to eliminate noise and others. Then you will have a fuzzification based on the rule base. You have a TS fuzzy or Mamdani fuzzy depending on a different kind of whether you are required to have a linear or the non-linear classifications. Thereafter, you have a interface mechanism, and you will take this is basically the supervisor and this is the data, and thus you have got a rule base, and this rule base is formed from fuzzification. You have an interface mechanism, and this is a fuzzy rule based. Then you will have to defuzzify, and ultimately there is a different method called centroid method and other methods. You will calculate the area, ultimately you will take out the time. So, ultimately it has to find it out what should be the one single input, the value of Kp. You have so many inputs. So, what should be the value of Kp and Ki, or in case of the washing machine, what will be the timing. So, that is the defuzzifications. There are many methods of defuzzifications, and thereafter post processing, because if it is generates some value, because if it is generates 9.3333666 as a value of the PI controller, of course, you cannot provide that value, and for this reason you have to give some kind of approximation, that is the post processing of the signal, and that value you will feed it to the your plant. So, this is a way you will work on the fuzzified system or the fuzzy logic as a main controller. We will continue with that. The universe of discourse, that is a mathematical term, of the input variable determines that where that universe discourse is, let us say theta, and your function is sine. So, your output is a sine theta, it varies between -1 to +1. Determines the required scaling normal and normalizations, that is something we require to do that to correct per unit operation. So, that is this kind of normalization is required to fit it to the model. The reference mechanism determines how the fuzzy logic operations are performed, and together with the knowledge base determine the output of the each fuzzy if and then rule. It is a causal effect, if this then this. Those are combined and converted to the Cripps value, that is a normal set value, with the defuzzification block. There are many way to defuzzify it, and the output of the Cripps value can be calculated by the center of gravity or the weighted average, and then the scaled output as a control signal is applied to the generating unit. This is a way any FLC will work, not only in case of the microgrid, but for any purpose. Generally, a controller synthesis based on a fuzzy logic for a dynamical system involves following 4 main steps. Let us see one by one. Define the states and the input output control variable and their various range. Whenever we say the states in the control system, we always understand the current through the inductor and the voltage across the capacitor, but its scope is beyond. So, it can have a different state also, different quantity at the state. Identify appropriate fuzzy set and membership functions and create degree of fuzzy members function for each input and output variable and complete the fuzzification. So, we have to, based on this thing, we have to complete the fuzzification. Thereafter, define a suitable interference engine and construct the fuzzy rule base. So, that is that require an expert system, if and then logic, using the control rule that the system will operate, and determine the defuzzification methods and combine the rule and defuzify the output and put it to the plant for action. This is a way the FLC or all the fuzzy logic systems will work. In consistent with the microgrid control, the first step of fuzzy, let us see that how it can be implemented in our microgrid. Controller design is to choose the correct input signals to the microgrid set points. So, voltage, current and other if it is a AC microgrid, then frequency, then PQ values, whatever may be the value required, you will take it from the set points. The output frequency, voltage, current, power and their derivative are commonly chosen as microgrid as an input of the fuzzy controller. Thereafter, what has it been done? These signals are then used as rule anecdotes, that is the if part. So, this is the if. So, this is now voltage is this, current is this, power is this, frequency is this is the if part. Load is this in the formation of the rule base, and the controller output is used to represent the content of the rule consequent, that means it is called the then part in the performance of the rule base. Fuzzification plays an important role in dealing with the certain informations which might be objective or the subjective in nature. Sometime we may have a mathematical correlations, so that is objective, and sometime we may not have a mathematical correlations, that is subjective. The fuzzification block in the fuzzy controller represents the process of converting the Scripps quantity into the fuzzy. So, you will say that the membership by a membership function. You say that till 40 it is young, then if someone is 35, within a membership function till 40 it is young. So, within a membership function he may have a value of 0.2, at 40 that value is 0. So, it is something like this. The fuzzifier converts the Scripps input to the linguistics variable using the membership functions stored into the fuzzy knowledge base. That has to be formed with due precisions as well as the informations. This rule base is a key of the FLC. You have to design the rule base with an expert system. Fuzziness is the fuzzy set characterized by the membership functions. There are different kind of function you can choose. Triangular, well, mostly in a TS fuzzy we choose triangular. It can be trapezoidal, it can be Gaussian, or it can be this kind of thing, sigmoid, and so many are there, and are common membership functions used in the fuzzy logic control. The parameter of fuzzy logic controller such as membership functions can be adjusted using an external tuning mechanism. So, we have to be tuned properly, and that is the usage of this. So, you have a fuzzy logic controller, you have a tuning mechanism, you got a data, so that is the inner loop, and you got a different set point, this is the outer loop, that is a feedback signals. The resulting controller is known as an adaptive, self learning or the self tuning fuzzy logic controller, if it can. So, you got a training mechanism and that will change the controller's parameters. Adaptive fuzzy logic controller has a distinct architecture consisting of the two loops, an inner loop, this one is the inner loop, and outer loop which adjusts the controller parameter as shown in the figure 2. The adaptive fuzzy logic controller is commonly used some other intelligent technique, it may be NN such as neural network in tuning block which have learning capability, because you know if and then you can change the weights and it will learn, and this combinations provides the, and it is said to be the neurofuzzy controller. The neurofuzzy controller is a fuzzy controller that uses the learning algorithm inspired by the neural network, backpropagation algorithm or any other algorithm, LMQ algorithm, and determines the parameter by processing the data samples. Now, let us take an example of fuzzy logic for the controller tuning. Let us take a simple example of the PI controller. The PI controller structure has been widely used in the power grids as well as the microgrid controller level due to its structural simplicity and the inexpensive in costs. And now you can, because it can be implemented, because integrator can be in analog domain, integrator can be put into the operation by an op amp. So, and again also can be put into the operation by an op amp. So, operation amplifier, one operation amplifier is sufficient to be used as a PI controller. So, for this reason it is quite inexpensive. Nowadays in a digital domain you can have a digital PI controller also that can be implemented by the various processors. The success of the PI controller depends on the appropriate choice of its gain, the value of the Kp and Ki. Assume the feedback signals to fed the PI controller to be ET, that is the error signal we sometimes say, then the control signal is generated by the PI controller in the continuous time domain is given by ut equal to Kp into Et plus Ki 0 to t integration of E tau of d tau. But ut is the control signal and Kp Ki are the proportional integral controller of this PI controller respectively. In practice the TI, the PI gains are usually realized by experienced the human experts. So, you have to, someone has to stay, but there are different methods, Nichols-Collins methods to tune the PI controller, but you require to know the plant model then, which may not be capable of achieving by an optimal performance of the microgrid control applications due to the nonlinearities, varying structures and uncertainties of the loads and the source. So, uncertainties comes from both, and here fuzzy logic can play an important contribution. Fuzzy logic can effectively use to tune the PI controller to improve the performance of the microgrid control system in comparison with the conventional tuning methods. Due to limits such as physical constraint and uncertainty in the microgrid, it may be difficult to meet an operational performance using a conventional PI controller. So, that is quite challenging, you require to have a mathematical model. The response to this challenge in this category, the fuzzy logic system is used as a supplementing controller to provide a compensating signal to the correct control action signal provided by the conventional PI controller. So, that is the advantage of the FLC. So, by adding the signal slightly corrects the PI controller output through the fuzzy rule, according to the online information is the task of the FLC that will fine tune the PI controller processes. So, what happened? This is a plant model, you got a PI controller, you got a fuzzy logic system, and PI controller will, this is the input to the PI controller, this is a FLC, you have a limiters, and ultimately you get the value ut which you are supposed to get from the PI controller, but it will fine tune the process of the PI controller. It may be summer, it may be subtractor, the way you are using that is a different opinion. The performance compensated the complementary signals can perform an effective role in optimally tracking and decomposing, because you may have something, if you have a large error, then output can be very high, and when you have a least error, but value of the Kp may be required to be reduced, but you cannot do that. So, for these reasons, this fuzzy logic based system can act very fast, and this is a oversimplified rather control scheme as it is shown in the figure 3. The intelligent fuzzy system collects the information about the microgrid response, that is ET, it can be voltage, current, frequency for the AC microgrid or the DC voltages for the DC microgrid, and PI controller output, and then recommends appropriate corrections of the control signals, that is the del U fuzzy. So, the fuzzy system performs an automatic tuner. The main component of the systems is an intelligent fine tuner for the conventional PI controller, and it includes the following entities, that is feedback through the ET signal, extract knowledge about the performance existing PI controller through the UPI signals, and embedded unit suggests the suitable corrections of the U fuzzy to be made with the final control action U, and thus this is your action U equal to UPI plus del U fuzzy, that will ensure that more proper action of the PI controller. And if you add up these things, what you can see that it actually have a, so this is the UPI, this is the Kp plus Ki, thereafter it has a PI controller, then you got an U fuzzy, and this now this PI controller is a function of the error as well as the U fuzzy, where Kp and Kpi are the proportional integer controllers, gains of the PI controller respectively, and the f dot, now it denotes the fuzzy logic function, it can be sigmoid, it can be anything else. Thank you for your attention. So, in this way FLC can be used with a parallel to the PI controller to further processes the PI controller. Thank you.